Try to recall if you've read a book or watched a movie that mentions immortality. This may be Harry Potter, where Voldemort's goal is to live forever. It may be Pirates of the Caribbean and Jack Sparrow's search for the fountain of youth to grant eternal life. Needless to say, we are no strangers to the concept of immortality. From the dawn of civilization, our ancestors were avid searchers of immortality. Throughout history, alchemists always had the ultimate goal of discovering the elixir of life, or the potion that would allow one to live forever. In fact, obsessed with the prospect of living indefinitely, 6 emperors from the Tang dynasty died from consuming mixtures of sulfur, cinnabar, and mercury. Nevertheless, we are also no strangers to the consequences of immortality. Our most influential literature centers on death and its importance to the essence of humans as emotional creatures. The myths, legends, fables, and folktales of our past have taught us that an everlasting life would simply be unbearable. In Greek mythology, Eos, the goddess of dawn, fell infatuated with Tithonus, son of the king of Troy. Tithonus begged Eos for immortality, and Zeus approved of this wish. However, as Tithonus grew old, withered, and isolated, he profoundly regretted his boundless longevity. A poem written by Alfred Tennyson tells the story of Tithonus from the immortal's perspective. Repentant of his choices, Tithonus reflects, "Why should a man desire in any way to vary from the kindly race of men, or pass beyond the goal of ordinance, where all should pause, as is most meet for all?" To answer Tithonus's rhetorical question, there are actually a few modern-day reasons to desire a prolonged life, though perhaps not an infinite one. Allow me to subject you to a small biology lesson. In 1965, Leonard Hayflick, former professor of medical microbiology at Stanford, discovered that our cells cannot divide indefinitely. They can only divide about 50 times. This is because each time one of our cells divides, the protective caps on our DNA, known as telomeres, shorten and lose some genetic material. This is known as the Hayflick limit. Cells that can no longer divide then turn into senescent or zombie cells, which secrete substances that cause nearby cells to deteriorate. As we get older, zombie cells in our body accumulate, which multiple studies have linked to an array of age-related diseases, including dementia, Parkinson's, Alzheimer's, cardiovascular disease, and cancer. These and other age-related diseases are responsible for the deaths of over 100,000 people every day. While scientists are working to find cures for these diseases, research takes immense investments of time and money. For example, annual federal funding for Alzheimer's research in the US recently reached over $3.7 billion. The National Cancer Institute spent $6.4 billion on cancer research alone in 2020. Now, even if some of the conditions were to be cured, others would quickly take their place. Thus, attempts to address each disease individually are both inefficient and futile. But there is another way that we could be combating age-related diseases. The discovery of the Hayflick limit revolutionized our understanding of these diseases, allowing us to see that their origins lie in one collective source: aging. Thus, we may be able to simultaneously confront these diseases by focusing on that source. We must cease treating aging as a natural process and instead view it as a condition that can and should be cured. While the idea of curing aging may appear complex, it simply implies messing with the Hayflick limit. We must find a way to slow cell division in order to delay the arrival of the Hayflick limit and pair this with a mechanism that inhibits the effects of zombie cells, as this will prevent further cellular deterioration. Scientists have already been diligently working to find this modern-day philosopher's stone. Curiously discovered on the soil of Easter Island, rapamycin is a drug with the potential to serve as an anti-aging treatment. Rapamycin acts on mTOR, a protein mechanism in our bodies that regulates cell division. Rapamycin tricks mTOR into stopping cell division and places the cell into a state of repair. A study at the UT Health Center of San Antonio found that rapamycin prevented the development of nerve and gland tumors in mice, consequently extending their lifespan. Furthermore, a study led by Darren Baker, a biologist at the Mayo Clinic in Minnesota, found that zombie cells within the brains of mice were responsible for neurodegenerative diseases. But clearing these zombie cells delayed the arrival of organ deterioration early in life, and consequently extended their lifespan. In summary, rapamycin is a drug with the potential to delay the arrival of the Hayflick limit. And senolytics are drugs with the potential to maximize tissue health. Thus, when paired, they may be able to eliminate the age-related diseases that affect us today, and thereupon extend our lifespan. And yet, the development of these drugs has been incredibly slow. Government health regulators, including the FDA, do not hitherto consider aging a disease, but rather a natural process. This precludes scientists from having a direct roadmap toward the furtherance of anti-aging treatments. Another deterrent to the rollout of these drugs is skepticism. Rapamycin and senolytics have been impossible to release as longevity treatments due to concerns that they promote cancer and tissue damage, but there is absolutely no evidence to undergird this. Even investors are skeptical of the ethical implications of curing aging. I find that the lack of progress on the elaboration of anti-aging treatments comes down to a visceral fear of change. As humans, we are innately perturbed by the possibility of novel circumstances. However, I profoundly believe in a necessity to look past this fear to ensure the health of mankind. Thus, allow me to destigmatize the prospect of curing aging. Many argue that access to longevity will inexorably be for the wealthiest. As for most drugs, this is likely to be the case during their initial rollout, simply because society is not set up to support the underprivileged in living healthier, longer lives. But cutting funding for longevity research will not rectify this issue. I do believe in a moral duty to make longevity available to as many people as possible. But the aging revolution must begin to take place immediately for the gross welfare of humanity. It's important to recognize that curing aging simultaneously implies curing the age-related diseases that kill roughly 100,000 people every day. When looked at it this way, aging is the gravest medical condition of our time. As soon as government health regulators, global organizations, and investors recognize this, most areas will eventually benefit from anti-aging treatments, as occurred with COVID-19 vaccines. We did not halt the development of COVID-19 vaccines out of a concern that they would reach underdeveloped regions more slowly. Additionally, healthier populations will be less vulnerable to epidemics and will consume less medical resources, which can be accordingly redirected to areas in need. Time and money usually invested into research for age-related diseases can also be reallocated to alternate public health needs. Now, as we have discussed, the people of our past and our present worry about how prolonged longevity could change us as humans. It's important to recognize that emerging biotechnology does not explore extreme changes. Anti-aging treatments are not a threat to our human essence as emotional creatures. Death is an inevitable part of the human experience, but curing aging does not imply immortality. It implies the extension of longevity via maximized tissue health and slowed cell division. Under anti-aging treatments, we will still be transient creatures, but the age-related diseases that affect us today will be absent, giving us a greater possibility of dying peacefully and with relative health. Thus, when I envision a world where humans live robustly and collectively to 150 years old or beyond, I see the possibility for mature societies that are home to stronger relationships. In our reality, prolonged longevity implies mass welfare, united societies, and death so peaceful and incredibly humane that it cannot be put into words. For the sake of mankind, we must echo the true implications of curing aging. Thank you.